Hello student, welcome to EPG Pathsala. I am Dr. Ajit Jaswal from Department of Anthropology, Pondicherry Central University, Puducherry. Today we are going to discuss about a module entitled Introduction to Human Growth and Development under paper Physical and Biological Anthropology. In this module we are going to study about the definition of growth and development, differences between growth and development. We will also try to find out the history of growth studies and also the method of studying growth. We will also give importance to different phases of growth and ultimately what are the factors that affect growth. Before starting this particular module, let me give you a small introductory information about growth and development. Growth is the only evidence of life was said by John Harry in the 19th century itself. It is not an elaboration of function, differentiation of tissues, nor the laying down of metabolic pathways as per Gross, rather an increase or decrease of some measurable quantity continuing throughout. As the life of an organism is an ongoing process, it must be thought of as an increase in some measurable dimension. It is a dynamic process beginning with the conjunction of two sets of genes in the fertilized ovum. It shows a basic underlying consistency and does not proceed in fits and start except in terms of certain increments. In Encyclopedia Americana says that physical growth comprises all the morphological modification that characterize the lifespan of an organism. Modification known to take place during human ontogeny, including change in the first kind, second change in the number, third change in the size, fourth change in the shape, and change in the position, pigmentation, texture of the body component. In quantitative term, growth is the increase in the living substances or protoplasm and include one or more of the following three processes. First, cell multiplication. Second, cell enlargement. Third, incorporation of material taken from environment. It is the biological synthesis of living tissue or protoplasm. Growth may be by cell enlargement, or maybe because of the nervous and muscle fiber. Maybe we can say that it is mostly by cell division. The cell enlargement may be growth of nerves or muscle fiber. Gross in 1978 has referred to two dimensions of development. One is the qualitative, which refer to the problem of cellular differentiation, and the quantitative one, which is concerned with growth and size determination. So development is growth coordinated towards the production of the complete organism from immature state to a highly organized, specialized and mature state. Development depend on the maturation and myelination of a nervous system. So the sequence is same for all the children, but the rate may vary. Development ultimately is a product of a contribution of hereditary and environment. Maturity is the measure of the functional capacity. Example like development of motor skill of a child, that is maturation of the skeletal and the muscle system. Watson and Lowry in 1962 have developed that both growth and development in a normal child parallel each other and any separation would be an artificial one. They restrict the term growth to mean an increase in physical size of the whole or any of its parts, which could be therefore measured in terms of inches or centimeter and pound or kilogram. Development, on the other hand, includes an increase in skill and complexity of function. Maturation and differentiations are frequently used as a synonyms for development. Used in this sense, it is evident that development is related to growth but is not the same. Let's try to define growth. Richards and Kwang in 1945 writes, growth is a fundamental attribute of living organism, manifested by a change in size of the individual or in the number of organisms in a unit of environment. Later on, Comas in 1960 says that growth is the increase in size of the various parts and organs of the body, and this increase is limited to pre-established constitutional hereditary factor and influenced by exogenous factor. Tanner in 1978 has observed growth as a product of the continuous and complex interaction of hereditary and environment or between the genotype and the changing environment, an interaction which is sometimes more complex than simple. Ensembling, it could be said that physical growth is the quantitative increase in size or mass which brings about irreversible change in the body, its organ, or in their size and form. Growth is often used as a synonymous for development. Development, according to Todd, is a progress towards maturity. It differs to a process of change in growth and capabilities over time as function of both maturation and interaction with the environment. Development, on the other hand, indicates an increase in skill and complexity of function. As per Todd, it is progress towards maturity, whereas maturity is the measure of functional capacity. Example, the development of motor skill of a child, that is maturation of the skeletal and muscle system. Now let's try to find out the differences between growth and development. As growth referred to increase in size which is in physical term, whereas development, it is overall change in the shape or form resulted in improving functioning. Growth result in measurable change, hence may be quantifiable, whereas in the case of development, it is a change or improvement in the functioning and behavior. So it bring about a qualitative change rather than the quantitative change in the case of growth, which are difficult to be measured directly, but growth can be measured. Growth may or may not bring development, but development may take place without growth. So we can say that development is a qualitative in nature, whereas a growth is a quantitative in nature. Development cannot be measured. There is no measurable limit is there for the growth, for the development. But for the growth, we can measure. We can give some unified value. It could therefore be said that growth and development in a children is a continuous and steady process. Growth pattern of every individual is unique, and different parts of the body grow at different rates. Before the 17th and 18th century, mostly the artists started using accurate proportion of the human body in their drawing. That is, by the late 15th century, Leonardo's drawing correctly rendered adult and child body proportion. The anatomical differences also started to depict in their work, and the children of normal proportion and growth pathologies. In 1651, physician William Harvey helped establish that the embryo is not a performed adult. Rather than during development, the human being passes through a series of embryological stages that are distinct in appearance from the form visible just before and after birth. Gallen wrote about the appearance of the fetus in the later stages of pregnancy. The first accurate drawing of fetus were made by Leonardo da Vinci, who dissected a 7-month-old fetus and stillborn, full-term infants. Other description of fetal anatomy and physiology followed Leonardo's work, notable by Versailles in 1555. The study of growth after birth began with the concept of infant and the children as miniature adult who had to only increase in size during the growing years. By the late 15th century, Leonardo's drawing correctly rendered about and child body proportion. Albrecht devised a method of geometric transformation that he used to accurately render proportion of the human head and face. The first longitudinal study on human growth was made by Count of France upon his son. He measured the stature of his son every 6 months from 1759 on the behest of Buffon, who included the measurement and his commentary on them in a supplement to his Historic Naturally in 1777. Another 18th century longitudinal study of growth is that of the student of the Karl School, conducted between the year 1772 and 1794, which included the sons of the nobility and of bourgeois. In 1835, Lambert published the first statistically complete study of the growth in height and weight of children. He was first to make use of concept of normal curve to describe the distribution of his growth measurement. After this, a vast number of growth studies were started to be made with the accumulation of dimensional data, mostly from the school, prison, hospital and military personnel. Along with this, several long-term longitudinal study also made its influx between 1927 and 1932. This include the famous longitudinal study at the Fields Institute or Yellow Spring, the Bolton Brush study at Western Reserve University, the Berkeley Growth Study, Guidance Study and Oakland Growth Study at the Institute of Human Development of the University of California, the Child Research Council study at the University of Colorado and the Harvard School of Public Health Growth Study. Buffon noted the seasonal variation in rate of growth, daily variation in stature, with the data on Montbilliard's son, with the study of Boas involving his research into the methodology of growth studies, demonstrating the importance of calculating growth velocities from individual rather than from sample means. The modern era of growth measurement and analysis begin. Now let's discuss about the method of studying growth. Growth among the children could be studied mainly by two methods. One is longitudinal method. In this method, the same subject or group of subject is measured rapidly year to year. Individual rate of growth and the timing of specific developmental events could be analyzed with data collected by this method. Data may be analyzed for individual rate of growth and the timing of specific developmental event. A birth to maturity study may take up to 20 years to complete with the help of this methodology. The principal drawback of the comprehensive longitudinal studies are as follows. First, an important one is the time. The time is taken to complete and the relatively small number of subjects that can be usually be followed. Next one is the longitudinal study are by their nature is costlier in nature and dependent upon the continuous cooperation of the subject. It is therefore essential that the highest of accuracy should be maintained in collecting and recording the data, and the method of analysis used should be those appropriate to the method of study, yielding the maximum and accurate information covering individual growth. Next one is the cross-sectional method. In this method, the subject was measured only once. Subjects of different ages are measured at a single point of time. This method provides a general description of age-related growth changes. A growth study could be completed within a very short span of time. In a comparative survey of children's growth in different populations, the concern is more with the means and variation of group of children than with the growth pattern of individual. Therefore, the information is usually from cross-sectional studies. Cross-sectional methods are adequate for studying distribution of various measurements in different individuals at different ages, and for constructing standard of growth attained like height and weight standard. In these circumstances, the relative case is and rapidly with which result may be obtained from a large number of cases make cross-sectional method preferable to longitudinal one. Cross-sectional methods are also obligatory in circumstances where continuity is not possible. Example, autopsy studies on internal organs. From a cross-sectional studies and the centiles of distribution could be calculated, which are often used as the basis for population standard. A large number of subjects are necessary for creating effective standards, but there are a number of limitations also. So, there are limitations to the usefulness of even large scale cross-sectional studies, like they tell us nothing about individual increment or increments from 1 year to the next. That is about individual rate of growth. Though they give us an estimate of the mean rate of growth of the population, they tell us nothing about the variability around the mean. Since this method mixes data of early, average and late maturing children, it results in a mean velocity curve that underestimates the actual velocity of growth of all the children during the adolescent spurt. In a clinical context, it is required to compare a given individual velocity or rate of growth with standard for velocity at his age. Semi-longitudinal or linked longitudinal method. Longitudinal and cross-sectional studies are complementary, and both are required for a full understanding of the growth process. For some purpose, a good design is that of linked longitudinal studies, that is, study covering the ages of 0 to 6, 5 to 11, 10 to 16 and 15 to 21. Efficient sampling of the population is crucial to obtain smooth joints in the data. Mixed longitudinal method. Maximum information could be extracted from a mixture of longitudinal and cross-sectional data as described by Tanner. It is called mixed longitudinal studies in which children have the liberty to enter and leave at different ages, giving various degree of longitudinality. Phases of growth. The beginning of life from the single cell stage proceed with many irreversible changes taking place, scientifically called growth and development, till the death of that single cell in the form of multicellular biologically complex being. This whole lengthy course could be broadly divided into two phases. One is called prenatal phases, that is before birth, which take place within the mother womb, and the postnatal or after birth phases. The prenatal phase or prenatal growth, in this case, the course of pregnancy is divided into three trimesters. During the first trimester, the multiplication of single cell, the fertilized ovum into millions of new cells take place. While dividing distinct group of cells begin to form having different rates of cell division. Eventually, they form different kinds of tissue, that is endoderm, mesoderm and ectoderm. After the tissue are formed, the first trimester is taken up with organogenesis, that is the formation of organs. By the 8th week, the embryo is recognizable human. By the start of the second trimester, the embryo is a fetus as the differentiation of the cell, tissue and organ is complete. The embryo grows slowly in length, reaching about 1 to 1.45 millimeter at 18 days during the first trimester. At 8th week after conception, the crown rump length is about 30 millimeter. By the 4th month, it is about 205 millimeter, and by the 5th month, 254 millimeter. By the end of the 6th month, it is between 356 and 381 millimeter, that is about 70% of the average birth length. Weight increase is less rapid. At 8th week, the embryo weighing about 2 to 2.5 gram or 2.7 gram. At the 7th month, the fetus weight only 700 gram. Growth rate increases during the last trimester when the development and maturation of the circulatory, respiratory and digestive system occur, preparing the fetus for the postnatal life. Postnatal growth, that is after birth. Prenatal and postnatal growth and development are one continuous process, but the incident of birth and beginning of extrauterine existence is an important dividing point. Life after birth has been divided into different period of growth differently by the various researchers. Like as Watson and Lowry in 1962, he defined the stages of growth as the growth period is prenatal, which is a period from 0 to 280 days approximately, ovum from 0 to 14 days, embryo from 14 days to 9 weeks, fetus from 9 weeks to birth, premature infant from 27 to 37 weeks, that is birth average 280 days, neonate, it is the first 4 weeks after birth, infancy is first year, early childhood, what is called also called as preschool, is from 1 to 6 year, late childhood, that is prepubertal, it is from 6 to 10 year, adolescence, in girls it is 8 or 10 to 18 year, in boys it is 10 or 12 to 20 years, puberty, average puberty, in the case of girls it is 13 year, whereas in the case of boys it is 15 year. Later on, Timiras in 1972 has described the stages in the life cycles are neonatal period, that is birth to 28 days, infancy is 2 months to 24 months, early childhood 2nd to 6th year, middle childhood 7 to 10 year, late childhood 10th year to puberty, which is typically occur between 12 year and 15 year in girls, 13 to 16 years in boys. In adolescence, the 6 year following puberty, adulthood, it is maybe primary and transition, that is between 20 year and the end of childbearing years, old age and senescence from the end of childbearing years to death, and later on death. Similarly, Scammon in 1942 has proposed another classification. According to this classification, there is a prenatal and postnatal childhood. Prenatal is it contains ovum, that is first 2 week, embryo first 2 to 8 week, fetus from 2 to 10 lumbar month. The infancy, it is from neonatal, the first 2 week, infancy from 2 week to 1 year, childhood period, that is early, middle, late. Early childhood is from 1 to 6 year, middle childhood from 6 to 9 year or 10 year, late childhood, that is in the case of boys, is from 9 to 10 or to 13 to 16 year, whereas in the case of girls from 9 to 10 to 12 to 15 year. Puberty in the case of boy is around 14 year, in the case of girls it is around 13 years. Adolescence in the case of boys is from 14 to 20 years, in the case of girls is from 13 to 18 years or 20 years. Maturity is from 18 to 20 to 60 years. Senility is after 60 years. Each growth period is characterized by its own tempo of growth. Bogin says that the approximate division between the periods are infancy, childhood, and adolescence. Infancy is birth to 3 year of age, childhood is 3 to 12 year of age, and adolescence is 12 to 18 year of age. Let's discuss about the early childhood. Increase in height take place up to 44% during the first year for child and 40% for girls. Weight increase is established at 143% in the male and 157% in the female. Head height is approximately 1/4 of the total stature. The spinal column at birth has a single dorsal curvature with anterior concavity. The leg lengthen almost double their length by the age of 3, but the arms do not double their length until the age of 5. Thorax is small in comparison with the abdomen and waist does not exist. Another characteristic of early infancy is general chubbiness with relatively large dimension of the trunk and head. In the case of middle childhood, this age is characterized by persistence of rounded infantile form and by a growth in width rather than in length or height. All deciduous teeth has erupted. The rounded body form of infancy persistent, it is between 2.5 to 6 to 7 years. Late childhood. This period is from the 7th year of the first sign of puberty, that is approximately up to 11 year of age in girls and 12 year in boys. There is a crisis of rapid linear growth of the body, particularly of the lower limb. Individual becomes thinner and the trunk loses its predominance and appears smaller with respect to the legs. Sexual morphological differences begin during this period. Puberty is in the case of boys is around 14 years, in the case of girls it is about 13 years. Adolescence in the case of boys is from 14 to 20 years, whereas in the case of girls is from 13 to 18 years or 20 years. Maturity starts from 18 to 20 years to 16 years, whereas senility is after 60 years. Adolescent. During this period, the future adult biotype or set adolescence in girls usually start and end 2 years before boys. It is from 11 to 12 to 15 to 16 in girls and from 12 to 13 to 17-18 years in boys. This period is characterized by the maturity of the genital organs and the appearance of secondary sexual character and modification in body proportion. Adulthood. The attainment of adult stature is one of the hallmarks used to make the transition from adolescent to adulthood. Height growth stops when the long bones loses their ability to increase in length. Reproductive maturity is another hallmark of adulthood. There is a lack of precisely timed or sequenced physiological event. Most tissue loses its ability to grow by hyperplasia, but many may grow by hypertrophy. Old age and senescence follow the prime year of adulthood. The pattern of decline varies between individuals, so there is no biological or genetic plan for the aging process. Factors affecting growth. The body proportion differences between geographic populations are usually explained in terms of genetic model. Studying the variation between population, another approach is also prevalent, that is, comparing children and adults of different national or geographic background living in the same or very similar environment. Genes do not directly cause growth and development, rather the expression is mediated by several biological systems operating within an environment appropriate for growth. Growth and development therefore depend on following factor. First, hereditary factor. Second, environmental factor. Environmental factor may be physical environmental factor or social environmental factor. And third is endocrine factor. Hereditary factor. Growth depending on hereditary factor is indicated by the difference found in the amount and or the rate of growth between children and adults of different national or geographic background living in the same or very similar environment. The genetical control of body shape is much more rigorous than the size. Familial correlations have been used to examine the hereditary component of variation in many body measurements. Studies focused on this area are many. A difference in height and weight velocity between the early, average, and late matures has been found by Hague and Tarranger, thus final height varying significantly between the late maturing boys and the other two maturing group of 6 averaging 6.5 cm and 4.2 cm respectively. Twin studies offer a more direct methodology for delineating the influence of heredity on growth. This genetical control operates throughout the whole period of growth. Skeletal maturity shows a close correspondence at all ages in identical twins. The time of eruption of the teeth, both deciduous and permanent, and also the sequence in which they calcify and erupt is largely determined by heredity. Heredity estimated that genetic factors account for about 34% of the variance is due to fetal genotype. Thus, higher the expected concordance in birth weight of dizygotic twins is likely to be due to the shared maternal environment, which sets some common limits to the growth of both twins. Similar long-term differences in growth between monozygotic twins of markedly different birth weight have also been reported by Faulkner. Theoretically, the familial correlation shows a measures of genetic similarity but are also equally a measure of environment. So, in hereditary estimate or hereditary factor, in a general, a particular environment may prove highly suitable for a child with a certain gene and highly unsuitable for a child with other. Thus, as per Tanner, it is very difficult to specify quantitatively the relative importance of heredity and environment in controlling growth and physique under any given circumstances. Environmental factor. There are number of environmental factors are there, like first one is altitude. High altitude environment, that is an altitude of 3,000 meters above sea level or higher, impose a number of stress like hypoxia, cold, high solar radiation, low humidity, high winds, and rough terrains. Since these stresses could not be overcome by any cultural or behavioral adaptation, so it results in differences in growth. Similarly, next factor is climate. A relatively large body volume and a small surface area is is the body type best suited for the heat retention in cold climate. In hot environment, a thin subcutaneous layer of fat would help minimize heat retention. For healthy individual, winter is a season of minimum weight gain for children and the time of maximum weight loss for adults. It occurs simultaneously with maximum height gain. It is suggested that seasonal periodicity in sunlight may act on human endocrine system so as to synchronize changes in growth regulating hormone activity with changes in sunlight availability or intensity. Next is season of year. Growth in height is on average found to be fastest in spring and growth in weight is fastest in spring and growth in weight is fastest in the autumn. Tanner says that individual children differ both in the time with they show a seasonal trend, which may be because of variation in endocrine reactivity. Next is nutrition. The effect of socio-cultural factor associated with economic condition was studied by Bharti and Basu. They say that they found an increase in the anthropometric measurement with the improvement in economic condition in both the sexes. Therefore, it could be seen that some of the socio-economic and socio-cultural factor which forms a part of the micro-environmental surrounding of the people sometimes affect the individual directly and other exert their influence through intermediate mechanism, that is nutrition. Next factor is migration and urbanization. Since migration redistributes the genetic, physiological, morphological and socio-cultural differences found in human populations, some effects are likely on growth and development of migrant and the recipient population. Next is socioeconomic status. Wilson listed four primary factors, that is higher socioeconomic status allow for a better nutrition, better healthcare, reduced physical labor for children and greater growth promoting psychological stimulation from parents, school and peers. The influence of education, occupation, income and housing on growth has become evident as well as the specific effect of each measure alone and in combination. Last one is the secular trend. The striking tendency for children to become progressively larger at all ages has been noticed. This trend is at present continuing in India and other third world countries. This trend in children's size is due both to earlier maturation culminating in final adult height being reached earlier and as per Tanner, this adult height has also increased. Better nutrition and generally improved environmental circumstances are usually cited as the cause of it. The secular trend, both in earlier maturation and in the greater size, is one of the most considerable phenomena of human biology as stated by Tanner. Now let's try to summarize the important environmental factors that affect the growth and development of children. Here the factors like high altitude or altitude, season of the year, climate, socio-economic factors, nutritional factors, socio-cultural factor, migration and urbanizations has a direct or indirect effect on the growth and development of the children. Internal environment. The effect of the internal environment on the growth of the individual, like hormonal influence. All the hormones in the body affect growth in some manner, like somatotropic hormone. It is a major if its major effect is on the linear growth in height. Thyroid hormone, it causes thyroxine and thyroidism thyroidothyrin and thyrotropic hormone are necessary for linear growth, that is called as T4 and T3 are necessary for linear growth. Adrenocorticotropic hormone stimulate the hypothalamus which in turn causes the adenohypophysis to secrete gonadotropic hormone. Similarly, luteinizing hormone and follicle stimulating hormone are secreted by the pituitary to regulate gonadal activities. So, these are the important hormones that affect growth. So, growth hormones and growth factor is synthesized and secreted by anterior pituitary gland. A hypothalamic hormone, growth hormone releasing factor, stimulate the synthesis of growth hormone and cause the release of growth hormone into the bloodstream. Another hypothalamic hormone, growth hormone releasing inhibiting hormone, also called as somatostatin, has an anti-secretory effect on growth hormone. Another class of growth promoting substances are called somatomedians or insulin-like growth factor. Other pituitary hormones such as prolactin, melanocyte stimulating hormone, vasopressin, oxytocin and their hypothalamic releasing or inhibiting factor are necessary for normal metabolic activities. The maintenance of the placenta of fetus, birth and other life-sustaining processes. A non-pituitary hormone plays similar vital role. Now let's try to highlight some of the important points that we have learned from this particular module. As we have already discussed that growth is the only evidence of life was said by Newman in the 19th century. As the life of an organism, it is an ongoing process. It must be through and thought of as an increase in the some measurable dimension. In a quantitative term, we can say that growth is the increase in the living substance or protoplasm and include one or more of the following three processes like cell multiplication, cell enlargement and incorporation of material taken from the environment. It is the biological synthesis of living mass or protoplasm. Growth may be enlargement of the cell but it is mostly by a cell division. Growth is an increase in the physical size of the whole or any of its parts, which could be therefore measured in terms of inches, centimeter, pound or kilogram. Development on the other hand, it indicates an increase in skill and complexity of function. As per the Todd, it is a progress towards maturity, whereas maturity is the measure of functional capacity. Example, the development of motor cell of a child, that is maturation of a child skeleton and muscle system. The first longitudinal study on human growth was made by Count Filbert of France upon his own son. He measured the stature of his son every 6 months from 1959 on the behest of Buffon, who included the measurement of his commentary on them in a supplement of his historic work in 1977. After a vast number of growth studies was started to be made with the accumulation of dimensional data monthly from the school, prison, hospital and military personnel. Let's try to discuss about the important method of studying growth. Longitudinal method. This is very important one, but it is time consuming method. In this method, the same subject or group of subject is measured repeatedly every year. By this method, individual rate of growth and the timing of a specific developmental event could be analyzed. But a birth to maturity study may be taken up to 20 years. Second is the cross-sectional method. In this method, the subjects are measured only once. So, it provides a general description of age-related growth changes. This type of study could be completed within a very short span of time, but nothing could be said about individual increment from 1 year to the next. That is about individual rate of growth is very difficult to say. Third method is called semi-longitudinal or linked longitudinal method. Linked longitudinal method studies covers the ages 0 to 6, 5 to 11, 10 to 16 and 15 to 20 and so on. So, to cover a study up to 21 year, less time than the longitudinal method is taken, but the results are as good as longitudinal method. Next and the last method is mixed longitudinal. As the term is very clear, it is mixing of several methods. In this method, children have the liberty to enter and leave the study at different ages, giving various degree of longitudinality. Now let us discuss about the phases of life, phases of growth. Generally, mostly it is divided into two phases, prenatal phase and postnatal phase. Prenatal phase are those phases which occur before birth, and postnatal are those phases which occur after birth. In the prenatal, it is further divided into infancy. The postnatal is further divided into infancy. In the infancy, the neonatal period is up to the first 2 weeks after birth. Infancy is from 2 weeks to 1 year. Where in the childhood, child is divided into early childhood, middle childhood and late childhood. The late childhood in the boys is from 9 to 10 year to 13 to 16 year. In the case of girl, it is from 9 to 10 to 12 to 15 year. Next is the puberty. Puberty arose immediately after that. That in the case of boys, it is about 14 year. In the case of girls, is around 13 year. Next is stage is adolescent. In the case of adolescent, the adolescent period in the case of boys is from 20 to 30 year, but in the girls it used to become little bit earlier than the boys. It is from 13 to 18 and sometimes 20 year. Next stage, next phase is maturity, then senility, that is start after 60 year. Next important factor that we have discussed in this modules is a factor affecting growth. There are a number of factors that affect growth. Let's broadly divide this factor into three broad categories, that is hereditary factor, environmental factor and endocrine factor. This environmental factor may be physical environment or social environmental factor. Okay, thank you.